Okay, so theta is measured in the interval between -180 and 180. As you can see, inclusive of 180, but not inclusive of -180. So theta has a problem. It's just like we did back in trig. We needed to work out which quadrants we're in. So the quadrants are now for complex numbers are theta, 180 minus theta, and then the negative of these two. So what's the negative of theta? That's negative theta. What's the negative of this? Negative 180 plus theta. Do you guys understand it when I say the negative of these two?
Yeah.
Put a negative in front and expand. So it's not technically what you know in all stations to central, because your domain's a little bit different. So new set of restrictions. That means if your complex number's here, your theta is theta. If your complex number's here, your theta is not theta, it's 180 minus theta. If your complex number's here, it's negative 180 plus theta. If your complex number's here, it's negative theta.
Can you get two answers for theta?
No. So it's not like, yeah. So it's not technically like where are they both positive or anything like that. It's just where is it located? So like technically, let's look at C. C says 4 minus 4i. Where is that located? First, second, third, or fourth quadrant? 4 minus 4i. First, second, third, or fourth. Remember, think about how you would draw this. X's, Y's.
Would it be in the fourth?
Yeah, it's right here. Yeah? So X is 4, Y is negative, so somewhere here. So the theta you should have should be a negative theta, not a positive theta or whatever it is. What about this one? Where's D located?
The second.
Yeah, so the theta you will get is wrong. It should be 180 minus theta.
Oh.
So that's the logic of it, and that's it. So you only care about the location, not two answers or anything like that. All right, good. Just before we get started on doing these, part of the new syllabus is also now to write them in exponential form. Don't stress, it's just this, R, E, I, theta. That's exponential form. What do you think R equals? What does R equal? Julia, why not?
R
Equals?
I don't know. Oh. A squared plus B squared.
Beautiful. And pretty much, what's the second one you think?
Oh, tan, sorry.
And theta equals?
B over A.
And then theta equals inverse tan B on A, right?
Mm.
So the only difference between mod arg form and exponential form is obviously exponentials have e's, they have exponentials. Mod arg have cis. So this is a bit different. But I mean, R and theta is still the same. All good? So what we're going to do, you guys, we're going to try to do all of these four. I'll do them. I'll do all four. We're going to write them in mod arg form and we're going to write them in exponential form, just so you can get the hang of them both. Don't forget, whenever we inverse tan, if you've been doing it my way, the way I've taught you guys, we've never inversed a negative. So don't forget, if this is B, we still keep it positive. because we have this trick, let's say. We don't inverse negatives, all right? Same trick that I would have done back in our 2-unit, 3-unit course. All right, let's get started. Enough talking. Example 1, A. I might just, oh yeah, it's okay. A, 3. All right, where does Z equal to 3? Z equals 3 is somewhere here. Does anyone know what R equals to straight away when they see a question like that? If it's just here. What's your distance? Sorry? 3. Yep. What does theta equal to?
0.
0. It hasn't moved up at all. So what's the answer if you said write it in mod arg form? 3 cis 0. And then you said write it in exponential form, 3e I 0, which we all know is 3, but still good to know how it's written in both forms. Any questions? I don't think we need this. B. Negative 4i. Draw it out. Always draw it before you convert. Negative 4i. Negative 4i is somewhere there. All right. Does anyone know what r equals to in the case like this?
4.
4. Exactly. The distance is 4. Right? Because that's all. You don't even need to do Pythagoras. That's just the distance of 4. What does theta equal to in this case then?
0.
No, 0 meant he hasn't moved at all, but he has moved on from my axis. Remember, it's starting from here. Wait, let's go back here. Theta be the angle which OP makes with the positive x-axis. So that theta is the angle it makes with that axis. So it's either you're going this way, or if you're going other way, it's negative. If you're going clockwise, it's negative, which means what should that be? Okay, let me scroll down. Julie, you want to take another guess?
Negative 90?
Yep, negative you mean?
Yeah.
If you say positive 90, you're talking about here. You got to be careful. Negative 90, and then do you want to tell me the answer in polar form?
4 cis negative, yeah.
And then in exponential form?
4 e, would you, oh, and then, yeah.
Something like that, maybe?
Yeah.
4e negative I pi over 2. I can't fit C and D here. Trying. Maybe we'll go up here, so at least you guys can have the answers on the one place when I send this to you. C, 4 minus 4i. Julie, you said it, it's somewhere here. But can you see now? Can you tell me the distance of this straight away? Not really, right? You probably have to do what? In this case.
Pythag?
Now you probably have to do Pythag, where Pythag is square root of a squared, so 4 squared, plus 4 squared, 16, so root 32. And then theta equals inverse tan B on A. Don't forget, no negatives, so 4 on 4. Inverse tan of 1 should be 45 degrees. But what should the answer be? Check your location.
Minus 45.
Check location. Let me just write that. Check location. Therefore, theta equals minus pi on 4. All right, and then obviously very easy, r cis theta. So z equals, I guess let's simplify this, 4 root 2, 4 root 2 cis minus pi on 4. And z equals 4 root 2 e negative I pi on 4. Going too fast with the 45 degrees and the pi over 4 here. Well, is that comfortable for us? Is it okay? Okay, do you guys want to try D maybe by cells for a sec? Draw it, just roughly. You don't need a full-blown diagram. You're not getting any marks for the diagram unless it says to draw it. There it is, so you know where it is now. Do your Pythag, then you'll find your R, and don't forget your angle. And then when somebody's ready, just tell me what your answer is for R, and tell me your final answer, I guess, for, oh no, tell me your initial answer for theta, and then we'll do the 180 together. These painkillers are good. I feel nothing. It's quite amazing. R, anyone have R?
6.
6. 3 squared. 3 squared is 6. 3 squared is. No, 3 squared 9. What am I saying? 3 squared 9. 3 squared 9. 9 times 3 is 18. 18. No, 27. 27 plus 9. 36. 36 square root. Yep, perfect. And then theta.
Initial answer is 30.
30 degrees. So then 180 minus 30 is 150. And then obviously you've got to convert that to radians, right? So divide that by 180. Put a pi. What's your final answer?
5 radians over 6.
5 pi over 6.
I'm sorry.
That's radians, yeah, that's okay. R cis theta, therefore z equals 6 is 5 pi on 6, or 6 is, no, what the, 6 e I, depending on what they wanted, right? It will tell you, write it in exponential form or write it in mod arg form. Good. Rav, any questions from you? No? Remember, you guys, as I said, whatever you learn, so now that you've learned this, that will be marks in the HSC, right? That's the way this course works. Not like advanced, where you learn everything and then you don't know what you get marked on. This, if I open up a HSC paper, you know what? Let's just do it now. Let's open it up here. 12 extension 2, complex numbers, exam, exams. Let's open up HSC. Yeah, that's HSC complex numbers. There it is. Express root 3 minus I in mod arg form. We haven't done this next part. Haven't got to those yet. Look at that. W is this, Z is this, multiply them together. So I'm just saying, whatever you get taught is tested. Here's another one that you did last week. W1 is this, W2 is this. Add them together, but this has to be conjugate. There's your square roots. And so on and so on. Anyways. Let's keep that here. Expressed in modulus argument form. Minus 1 plus I. There is root 2 cis 3 pi over 4. All right. I think it's clear. Just saying, whatever you learn is what's tested. Just keep that in mind. Okay. Let's do example number 2. Another trig one, just like I did last week. I did an annoying trig question just to show you that sometimes you got to think creatively. Let's see if we can use that today. Queenie, you can guide me through this. So let's do this. This is A, this is B. All right, what does R equal to?
Root 1 plus cos theta all squared.
1 plus cos theta all squared plus?
1 I sine theta all squared.
Incorrect. Close.
Sine theta.
Yeah, just the sine. You don't include the I. Remember, the I is just telling you that that part there is imaginary. But the distance you've gone is just the sine theta. Make sense, Queenie?
Yep.
Yep, all good. All right, and then what would you do after this?
Expand the 1 plus cos theta squared.
1 plus 2 cos theta plus sine squared. Cos squared plus sine squared is 1. 1 plus 1 is 2, so we're at this stage. Right?
Yeah.
And let's leave it for now. Theta. Well, let's write tan theta. What is tan theta equal to?
Sine theta on 1 plus cos theta.
B on A. And then look, what an ugly, R. If you left this would have been R. And then cis, and then inverse tan of this monster. It just looks bad, doesn't it, to you?
Yeah.
And that's why last week I introduced you guys to just trying to make sure you guys can think of your double angles and hopefully reducing a lot of these stuff, right? Because like you got to say, why was this even a 4-unit question if that's all I had to do? So for it to be a 4-unit question, they just want you to maybe do a little bit more. So, Queenie, do you by any chance know what sine theta equals to from its double angle?
I do not remember.
That's okay. Then do you know what the double angle of sine theta is? So sine 2 theta. What's the double angle of that?
Sine. Is it sine theta cos theta?
Yeah, and you're missing the number in front.
2 sine theta cos theta.
It is 2 sine theta cos theta. So if you didn't want sine 2 theta, if you only wanted sine theta, what have you done to the angle? Only to the angle.
You halved it?
You've halved the angle. You don't halve this 2. That's not an angle. So be careful. Because you've halved the angle, you halve the angles. Easy?
Yeah.
So I always remember the first one, and then obviously you can divide by 2 quite simply. Good. And then while we're here, do you know the expansion of cos 2 theta in terms of causes only? Starts with the 2, I think, as well.
I do not remember.
No, that's okay. Does anyone know it?
Is it 2 cos squared theta minus 1?
Yep, that's a good one. And then divided by 2, divided by 2. That's completely allowed. Julia, all good?
Yeah.
You guys got to get flexible with that thinking, I guess. And that's okay. It's good that you're exposed to it. So hopefully if you get a hard extension 1 question and you're realizing something's failing, maybe you can start introducing this concept. Sine theta. 2 sine theta on 2 cos theta on 2 over 1 plus. Why did I choose cos, if you guys are wondering? Because I know there's going to be a minus 1. When I have a 1 and a minus 1, it'll cancel out. That's why I chose this. Otherwise, as you know, there's 3 versions of cos 2 theta. Beautiful. Then what do? Well, 1 and 1 cancels out. 2 and 2 cancels out. Cos theta on 2 and square cancels out. Look what I end up with. Sine theta on 2 on cos theta on 2, which simplifies to what?
Tan.
Yeah, and that becomes tan theta on 2. And then when you inverse it, what do you end up with? Maybe I should have chosen a different letter. All right, if you guys don't mind, otherwise it looks like to you right now, it looks like theta equals theta on 2. You shouldn't have chosen tan theta here. Because the question is saying thetas, so that you don't get confused, let's just change this to alpha. All right, so they're not the same letter. Is that okay? All right, it's still the angle of my cis theta, but it's just so that you don't get confused. Are you guys okay with that? Yep. Any questions about anything I've done here? So you can see something that was weird. Look how nice it actually becomes. It actually becomes theta on 2. Let's do the thing. Yeah, go ahead.
Tan inverse. So by doing tan inverse on both sides, it just cancels.
Well, doesn't it? Again, think of equations for yourself. If you had x squared on this side and let's say 9 squared on this side, what happens to the squares when you square root them?
They disappear.
Right, they disappear. What if this didn't have a square root? If this was just a square, well, that's when, yes, when you square root this, you're actually square rooting this, and it doesn't disappear. But if they're the same, technically, when you're going to do the opposite of this side, it'll just cancel out anyways. So, yep, when you inverse tan here, you'll inverse tan there. It's gone. Well, here's another one that you know of. Look, log x equals log 2. What do you do to get rid of the logs?
Inverse.
Inverse it, which is exponential. Once you do that, it's gone. So you cross out the logs. X equals to 2. True. They're both logs. Just cancel them out. Essentially. Yeah. Good. Rub. All right. So where are we? Back to this one. 2 plus 2 cos theta. Cos theta, which we'll still choose this one here. Minus 1. Expand. 2 and 2 cancels. What's the square root of 4? What's the square root of cos squared? Hey, that actually worked out nicely. So the answer is R cis theta on 2. Or in the other form, exponential form, R E I theta on 2. All right. Any questions?